Hello everyone, my name is Aruhi and welcome to my channel. So guys, in my today's video, I'll show you how to use Vision Transformer on your custom dataset for image classification. For my today's class, I'll execute the whole example on Google Colab notebook. I'll show you step by step how to prepare your custom dataset first for image classification problem, and then how you can train your model on Google Colab and how to test the model then. So first thing is you need to log in into your Gmail account, and after that in your My Drive, here you can see I have created a folder. You can also create the same folder or you can create any folder, and inside that folder I am going to paste all the files and folders which are required for our today's class. First thing is this custom dataset. You also create a folder with the name of custom dataset, and inside that folder create these two folders. Now what I'm going to show you is how to prepare your custom dataset when you want to perform image classification using Vision Transformer. So the first step is create a custom dataset folder, and inside that create these two folders, train and test. And inside train folder we have two folders, daisy and dandelion. So guys, these are the two classes which I want to give to the Vision Transformer model, and I want that Vision Transformer model should be capable of identifying whether the input image, which is the image which we provided to the model, belongs to dandelion class or a daisy class. So in the same way, if you are working on 3 different classes or 5 different classes, you will make a separate folder for each class, and the name of the folder should be the label of the class. So in my case, this dandelion means the images which are present in this folder, they all belongs to dandelion class. We have images of dandelions. Let me open few images and show you. See, this is dandelion, this is another image of dandelion. So all the dandelion images are present in this dandelion folder. In the same way, in daisy folder I have placed all the images of daisies. Let's open this folder also and see few images. See, here we have daisies, right? So in this way you will create separate folder for each class, and the name of the folder would be the class label of the images which are present in that particular folder. So this is how you'll prepare your training dataset. And in test folder also you will have same number of folders which you have in train folder, and again in these folders you're going to have few images on which we will test our model later. Okay, see, in dandelions we have dandelion images, and in daisy we have images of daisies. So this is how you prepare data for image classification problem. Now let's go back to our folder. See, I'm working in this folder, AI demos. Okay, so this part I've told you, engine.py and helper function.py, and this with transformer module.py. This I will explain you when we will use in our code. Okay, and this is the Google Colab notebook where we are going to write our code, and this is the trained model. Once you train your model, so we are saving it. Let me delete this for now. Okay, so we are deleting it. We will perform all the steps and finally you will have your trained model over here. Okay, so let's start the work. So now I'm opening this train test Colab notebook. So in Drive we have My Drive, and in My Drive we have AI demos, and here this is the notebook which I'm showing you over here, right? First thing is to go to edit, notebook settings, and make sure that T4 GPU is selected. If CPU is selected, that means your Colab notebook will use CPU while processing the whole code. But if you want to use GPU, then you have to select the GPU and then click on save. This is the first step. Next task is, now let's see what all modules are needed to run our today's code and what are the versions. Okay, so let's start by checking the Python version. So for our today's tutorial vision transformer, we are working on a PyTorch framework. So this is the PyTorch version. So guys, you'll see that we haven't installed anything yet, but still we are getting this PyTorch. So this is by default, this is installed, so there is no need to install it again. So if you want to work on some specific PyTorch version which is not installed, then you need to perform the steps to install that particular PyTorch version. Okay, so but in our case we'll work with this latest version only. So you can see that PyTorch version is 2.5.1 and it is compiled with CUDA 12.1. It means that your PyTorch will use GPU for its work. Okay, and now I'm going to import few modules. So these are the few modules which we are going to need. We are importing Torch, Torch Vision, and then Matplotlib. Matplotlib we are importing because we will display the predictions with the help of it. And Torch and Torch Vision we are importing because the code which we are going to write today, it is in PyTorch, so these modules are required. So let's run it. So here in next cell we are writing device equals to CUDA if CUDA is available, else CPU. So what it means is we are saying that if GPU is available, then use GPU for the processing, otherwise use CPU. Now let's provide the path of our training data and test data. So where is our training data? In the train folder, which is in custom dataset folder, and custom dataset folder is in AI demos. See, AI demos, custom dataset, and train. Here is our training data. So provide the path. In the same way for test data, you will provide the path. So guys, if you have created the folder with this name only, then this path will work. Otherwise, you need to make changes in the path as per the folder names which you have used. Now let's create a data loader. Data loader function will help you to load the training data and test data. It will help you to prepare the dataset in the format which your vision transformer model will accept. So for this, I have this code. So let me explain you this code. See, this is the code. First, we are importing these modules. And after that, we have created a function with the name of create data loader. And here you'll see train data variable. Over here, we are loading the data from train underscore dir. What is there in train underscore dir? The path of the training data, right? In the same way, in test underscore data variable, we are getting the data from the test underscore dir, this, okay? And then class names. See, in class names, we are fetching the names of the folders which are present in train folder. Okay, so train data dot classes. What it means is that in training folder over here, we have these two names, Daisy and Dandelion. These are the two folder names, and these are our class labels also. So that's what we are fetching over here like this. Now we are creating one data loader for train data loader, and another data loader is for test data loader. With the help of train data loader, we will load the training data, and with the help of test data loader, we will load the test data. Here, see, in train data loader, you will provide the training data, right? And in test data loader, you will provide the test data. And here we are providing the batch size also. And in training data, we are writing shuffle equals to true, but in test data, shuffle equals to false. Okay, so this is we have created the create data loader function, but we are not using it right now. Now in next few cells, I'll show you how to create the training data loader and test data loader using this create data loader function. Okay, so let's execute it first. Before showing you how to create training data loader and this test data loader, I am writing this code also. So what this cell says, image size is 224. What it means is, guys, the original paper of vision transformer, in that paper they have used the image size 224 into 224, and in my today's tutorial I am following all the same values and parameters which they have used in original paper. So that's why whatever images we have in our training folder and whatever images we have in a test folder, we want to resize all those images to 224 into 224. So for that I've written this function transform.compose. We are resizing all the images to size 224 into 224, and then we are transforming them into tensors, because then only your PyTorch model will accept that data. Okay, so that's what we have written over here. Now see this batch size 32. This you can change as per the resources you are using, because sometimes what happen is if you are using batch size 32 and you are getting resource exhaust error, right? So then you can reduce this size. Here in this line we are using the create data loader function to create training data loader and test data loader. Okay, see, we have three variables over here: train data loader, test data loader, and class names. And from this create data loader function, which we have defined above, see, we have created this function over here, right? So now we are calling this function to actually create the train data loader for train and test data. So once you get the train data loader, test data loader, and class names, I'm just trying to print what we have in it. Okay, we are just trying to see after performing this step what kind of data we have in these three variables. So let's run it. See, this is what we have in training data loader, this is what we have in test data loader, and this is the class names. So Daisy and Dandelion are the class names. Now we have created the data loaders. Now let's try to see few examples using this train data loader in order to confirm, in order to verify whether the data loaders which we have used, whether they are loading the data properly or not. So how we need the data? We need image, and with every image there should be one label, class label, right? So this is the right format of loading the data. So when we provide data to model for training, we provide image and the corresponding label. So using this create data loader function, we prepared our training dataset and test dataset in such a way that for every image there should be one corresponding class label. So now let's in next cell we will try to print one image and the corresponding label, and we will see whether these data loaders have loaded the data properly or not. So for that we have this code. See, first we are getting the batch of images. Here we will get the images in batches, here we'll get the labels, and from train data loader we are getting the data. And from that batch we are fetching single image and its corresponding label, and then we are printing the image shape and label, and then using this matplotlib we are showing the image and its corresponding label on it. Let's run it. See, we have this image. For this image, this is the Dandelion is the class label. So our dataset is loaded properly. For all the images, we will have image and the corresponding label. So our dataset is loaded properly. Now we will train the model. So to train the model, I have this script. Okay, first let me show you these modules. See, what I'm doing is I'm importing these modules. Hit enter. So what these modules are from AI demo. What is AI demos? AI demos is the folder in which we have the entire code, right? And then here you will see that with underscore transformer underscore module.py. This py file have the code of entire vision transformer model. Okay, so in vision transformer model, how we work? First, we convert the image into patches, then we flatten those patches, then we add position embedding with it, then we provide that data to encoder, transformers encoder. There we are using this multi-head attention layer. Like this we work, right? So all that work we have written in this file. See, first we have a patch embedding class. This class In this we are using patch size 16. So in original paper the patch size used is 16, so that's why we are using patch size 16, and we are converting the image into patches, then we are flattening that image. Okay, so after that, this is the another class. In this class we are writing the task of multi-head attention layer, and then scroll down. Here you will see the transformer encoder block. The code of that is here. Then this is the entire vision transformer model. In this model we have we have prepared this class in such a way that we should have all the layers which are there in the original vision transformer model. Okay, so everything related to vision transformer is mentioned in this file. So here you can see from AI demos we are importing that Python file which I've just shown you, where we have the code related to vision transformer, and we are importing all the classes: patch embedding class, multi-head self-attention, MLP block, transformer encoder, and the ViT. Okay, so this class is the class which have the whole vision transformer model architecture code. So next, this is what we are doing. First, this ViT model we are calling over here, and number of classes. How we are providing the number of classes? Length of class names. So remember the class names we have over here. See how many classes we have: Daisy and Dandelion. So the length of class names will be 2. So that's what we are providing over here to this ViT model. And then we are writing the optimizer. So optimizer we are using is Adam optimizer, and learning rate is this, betas and weight decay is this. All these values are according to the values which are there in the paper. And then this is the loss function we are creating over here. So which loss function we are using? Cross entropy loss. Why? Because this is a multi-class classification problem. So in my case, I have only 2 classes, Daisy and Dandelion. But let's say the dataset, custom dataset you are working on, and it has 3, 5 or 7 different classes. Then you need this cross entropy loss function to know the loss. Okay. And you can change these values, right? And after that, see, from this AI demos folder, we are importing another file, the file with the name of engine.py. In this engine.py file, I have written the script to train the model and to test the model. So here we have 2 separate functions. One function is used to train the model, another function is used to test the model. So here you can see we are importing this engine.py file, engine.train. So this train is a function which is inside this engine.py file. Let me show you. See this engine.py file. First we have a train step function. In this train step function, see what we are writing. We want to train the model and we want to store the training loss and the training accuracy. The initial values are 0, but these values will be, we will store the values over here epoch wise epoch later on. And then we are running the model. We are getting the predicted value. Okay, let me explain you this part a little bit. See, X is input, Y is output. X in our case is our image, Y is the class label. So here this is our model, vision transformer model. Okay, so to this model we are providing the images. What kind of task we are performing over here? We want to train the vision transformer model in a way that if we provide it an image, it should give a class label, right? So model, we are providing the image to a model, and model is learning to provide the class label to it. The class label will be predicted Y value, right? So Y underscore predict will have the class label which model will predict. Once model predicted the label, we want to check whether the predicted label is correct or not, right? So for that, we are using the loss function. And which loss function we are using? Remember, here I've explained you, we are using this cross entropy loss function, and it is stored in this loss underscore fn. Okay, so yeah, here. So in this loss function, loss underscore fn, to check the loss, how we will know whether the predicted value of model is correct or not? How we'll get to know that the predicted y value, means the class label which model predicted, is correct? We will compare the predicted label with the actual label, and then we'll get to know that whether the predicted output is correct or not. So that's what we are doing. So this loss underscore fn function, we are providing the class label which model predicted, and we are also providing the actual label of our dataset. Actual label means in this custom dataset folder, this is the train folder. So inside dandelion folder, we have all the dandelion images. So this dandelion over here is the actual y value. Okay. And the predicted y value we are getting from model, or both the labels, actual label and the predicted label, will go to the loss underscore fn function, and on the basis of that we will get to know how much accurate our model is working. And on the basis of the loss, then we have a optimizer. Optimizer is used to when we train any AI model, there are two passes. One is forward pass and another one is backward pass. In forward pass, we provide data to the model, and model learn to solve the particular problem, and then we finally get the loss value. On the basis of that loss value, we try to improve the model in the backward pass by updating the weights, and while updating the weights, we use this optimizer. And loss dot backward means the backward pass. And then, so this is how, see guys, the code which we have over here is the basic AI model code. So every AI model get trained like this only, forward pass and the backward pass. We use optimizers, we update the weights, and then we train the model again. For every epoch we perform this kind of task. So all that code is written over here. Okay, so that's what I'm saying. We are using train function from engine, and we are providing the training data, we are providing the test data to it, we are providing the optimizer, we are providing the loss function which we have over here, and we want to train the model for 10 epochs, right? So like this we train our model, and once the model get trained for 10 epochs, I want to save that model so that in future if we want to use that model, there is no need to train that model again. Once we save that trained model, we can call this trained model whenever we want to use the model for the particular task. So right now here we don't have this file wit underscore trained underscore model dot pth. See, we don't have this file over here, but when I'll execute this code, and after 10 epochs, when the training gets completed, on this side under this folder you'll see this trained model. Okay, let's execute this cell. See, training started. See, training started, epoch 1. Training loss is this, training accuracy is this, test loss is this, and test accuracy is this. And after the second epoch, you can see the test accuracy is same as the first epoch, but the loss is this, right? So like this, the model will be trained for 10 epochs. 6 epochs are completed. After, see, you can see that the test accuracy in the last 3 epochs is same. And if you see the training accuracy is also around 47% and 48%. So guys, we are getting the training accuracy and test accuracy like this because we have a very small data set, and also you can try to change the learning rate over here, right? So the learning rate which I'm using is very high right now. You can use the learning rate like 0.0001, and then you can train the model. You will see the difference in the output then. Okay, see, now the last epoch is going on. After that epoch, you'll see the trained model on this side. The 10 epochs have completed, and now in this side you'll see this wit underscore trained. See, wit underscore trained underscore model dot pth. So this is the trained model. Now using this model, we will make the predictions on unseen data. Okay, before that, if you want to plot the training accuracies and the loss, then you can call this plot loss curve function, which is present in helper function. See, this is the helper function.py file. So this function file have two functions. One function is to plot the accuracies and the loss plots, and other function I'll show you in a minute. Okay, let's just print it first. See, here you can see the training losses. Okay, let's just do like this. So training loss and training and test accuracies. Okay, and after that, now we will try to perform the inference on unseen image. See, what I'm doing is I'm importing. Okay, here you need to write. So from helper functions, we are importing the another function, predict and plot image. So this function is responsible to show you the predicted image with the class name. This function is also present in this helper function.py file. So this is the test image on which I want to perform the testing. See, this image is over here, which is in AI demos only. Okay, so predict and plot image function, this function, we are running the vision transformer model, we are providing the image to it, and then this function will display the output. See, this is our image. Our model predicted class Daisy and the probability is 57%. Means our model is 57% sure that this image belongs to Daisy class. So this is how you can perform image classification using vision transformer on custom dataset, and the link of this code is given in description section. You can try this code. And guys, if this video is helpful, please like, share and subscribe my channel. Thank you for watching.